All right, today we are going to be talking about dilutions, and when you think about something being diluted, you're talking about it being having a less of a concentration. Okay, so we're talking about a method for making a solution that's less concentrated. And what we do is we can't take a solution we already have and then take out some of the solute. We can't remove moles of something, right? But what we can do is we can add more solvent. All right, so what we do is we add our solvent to our solution and we make it less concentrated. All right, so looking at our molarity formula, we've got M equals moles of solute over liters of solution. Okay, so when we're doing dilutions, this moles stays the same. And what we're doing is we're changing the amount of liters there are in the total solution. So we're changing this, we're adding more liters, and you do that by changing the solvent. Right? Most aqueous solutions, well, all aqueous solutions are going to be dissolved in water, so usually you're adding water. All right, so a common application of this is a lot of parents, when they have young children, won't give them 100% apple juice. Okay, they'll put in a little bit of apple juice that they get from the container, and then they'll fill it up with water so that the kids can start getting different types of tastes, but not too much sugar. Okay, so that's a common thing that we do dilutions for every day. So think about what you know about dilutions already. Okay, so the moles of solute is going to be the same before and after the dilution. What changes is the solvent. All right, so what we can do is we can actually do calculations with this using this formula here. This is molarity, concentration of your first solution times the volume, the total volume of your first solution, equals the molarity of your second solution, which is usually what you're looking for. Okay, times the volume, the total volume of your solution once it's diluted. Okay, so just pay attention to whether a question is asking you, is this a how much water is added, or is it the new volume of the solution? So you have to really pay attention to the way that questions are being asked here. All right, so here's a little picture for you that helps describe what's happening here. So you can see we've got our original concentration and an original volume right here, just 1 little liter in the graduated cylinder. And if we add more solvent, we just add water to each of those. Okay, you can see the color in the solution changes. So we could do this with food dye, and we could see that, you know, a pale color will show us that we'll have less particles. So you'll see here, if I took a cross section, I would have lots of particles really close together, and these are my moles of solute. Okay, but on this last one, I don't quite have so many close together. They're a little bit farther apart because there's water molecules in between them. There's solvent molecules in between them. Okay, so that's just an idea about what a dilution looks like. I also wanted to tell you about a serial dilution, and basically this is a series of dilutions that just happen right after one another. Okay, so if you do one dilution, just dilution. If you take that second dilution and dilute it again, that's going to be a serial dilution. Okay, and we're going to do one of these in class together. So you can see this is a 100 molar solution. If I took 1 millivat, put it in a new graduated cylinder, filled it up, so there were 10 mils total, I would have a concentration of 10 molar. All right. Then if I took 1 milliliter of this, put it in here, again, filled it up with the rest with water, my concentration would go down. Take this, move it down, keep moving it down. Okay, so basically I'm taking a few moles of the solute and I'm adding the solvent to fill it up to be the correct volume. All right, so that's a serial dilution, just so you get the concept. An example of how you would do a basic calculation for a dilution is as follows. So 150 milliliters of water is added to 100 mils of a 3 molar solution. What is the concentration of the new solution? So I'm looking for the concentration of the new solution. I've got some information. All right, so I've got 150 milliliters of water is added to. So that gives me a little indicator. I'm going to draw a little picture. This is my beaker, okay, and I've got 100 milliliters of a 3 molar solution. So I've got 3 molar solution, and I've got 100 mils, which is 0.1 liters. All right. Then what's happening? This is 100 mils. And then what I'm doing is I'm adding to it 150 mils of water. Okay, so my volume is actually going to go up to 250 milliliters total. Okay, so that's what's actually going to happen is you're going to see that water level, the solution level increase. Okay, so make sure that you're not taking this right here as your V2. Our V2 is actually going to be 250 mils. So I start out, my M1 is going to be 3 molar. My V1, like we said, is 0.1 liters. I just divided by 1,000. And then I don't know what my M2 is. That's what I'm looking for. And my V2, I'm going to do 100 plus 150 is 250 milliliters of solution, and that's going to be 0.25 liters. And again, it's important in this formula that you're using liters, and that's because this right here is moles over liters, so you want your liters to cancel out. And if you look at the way that this is set up, you're going to have the same number of moles of solute before and after the dilution. Okay, that's where this is really, really strong. All right, so here's what we're going to do. We're going to start out by plugging these into our formula. So I've got 3 molar times 0.1 liter is our second molarity, which is what we're looking for, times 0.25 liters. Okay, so now what I'm going to do is I'm going to divide by 0.25 on both sides. 0.25 liters. Okay, my liters are going to cancel out. And I'm going to get my new molarity. Okay, so my new molarity is going to be 1.2 molar. And that makes sense. I'm going from 3 molars, a concentration of 3 molar, and then I'm adding water. Okay, so I'm diluting it. So I should have a molarity that's less than, I've got 1.2 molars. Okay, make sure that you have a molarity that's less than what you started with if you're doing a dilution. Okay, all right, well, nice work, and we will work on this a whole bunch in class together. Awesome.